Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss the problem asked in today's LeetCode Weekly Contest 465. So let's start with the first problem. It says you are given two integer arrays, order and friends. So order contains all the integer from 1 to n exactly once, and each would represent an ID of the participant in the finishing order, right? So these are the finishing order of those participant, and you are also given friend that contains the ID of your friends, right? And they are sorted in a strictly increasing order, and each ID of the friend is guaranteed to be present in the order array. So each friend ID will be present in the order array. Now what you have to do, you have to return the array containing your friend's ID in the finishing order, right? So ultimately what you have to find out. So let's take the first test case. So order is 3 1 2 5 4 and friends is 1 3 and 4. So you have to return the order of these friends in the existing order array. So for friend 1 3 and 5, see, 1 3 and 5, so right, so the actual order of 1 3 and 5 is 3 1 and 4, 3 1 and 4. In the second test case your friends are 2 and 5, right? But in the existing order array the actual order is 5 and 2, right? So it's pretty implementation problem, I would say. Just keep on scanning in the order array, and if it is present in the friend array, just insert to your answer. That's it. So yeah, I'll directly jump over to the code. This is a pretty implementation problem, right? So yeah, this is the code of first problem. This is my answer array. Now what I'm doing here, I'm scanning through each of the ID that is present in the finishing order, and I'm just checking if this number is present in the friends array or not. So I'm using a standard STL binary search function. So it just check, since it is mentioned that all the IDs would be sorted in the friends array, right? So we can apply binary search. So if the binary search in this array for the ID is present, just keep insert into your answer array, and at the end return the answer, right? So yeah, this is the code of first problem. Now let's look at the second problem. This is the second problem asked in today's contest. So it says you are given two integer n comma k. Now you have to split the number n into exactly k positive integers such that the product of these integers is exactly equals to n, right? And we have to return any one split in which the maximum difference between any two number is minimized, right? And you may return the result in any order. So the important point is this: you have to return the most optimal split such that the difference between mean and max is minimized. So okay, so let's say for the first test case 100, and so 100, so there are multiple ways to possible to split into two groups. One is 10 comma 10, one could be 4 comma 25, but if you are using 4 comma 25, the difference between mean and max is 21, right? But here the difference is 0 itself. So this is the most optimal ways to split into two groups, right? And similarly here for 44, uh, one could be 1 comma 44, for example, sorry, 1 1 and 44. This is one of the ways to split, but if you split in 1 1 44, the difference between mean and max is 43, but here the difference in mean and max is just 9. So this is the most optimal uh, ways to split into three numbers, right? Yeah, this is the number theory problem. Let's see how we can approach it. And problem, essentially a backtracking problem. Backtracking problem. So what we will do, so let's say in the first discuss we are given n 10 and k equals to 5, right? So what we will do, we will first uh, try to find all of its divisors, right? So for 100 the divisors are 1 2 4 5 10 20 25 50 and 100, right? These are the divisors of 100, and we have to kind of split it into a group of k numbers such that its multiplication, like it multiplies to the number n, right? And the difference between maximum and the minimum is minimized, right? So if you split the given number n into k k numbers such that it multiplies to n, right? So let's say these number are f1, f2, f3 till fk, right? We know that f1 multiply f2, f3 of till fk equals to n, right? So since these are also, so f1 into f2 into f3 up till fk equals to n means that all these individual numbers are a divisor of n, right? They can easily divide given number n. So it says that all these number f1, f2, f3 must present in this divisor array, like means that it, since it's a divisor of n, it would present in the given divisor array. So what we will do, we will choose one of the divisors here. So let's say I choose 5, right? 5 at the first place. Now the next job is to find, so let's say this is my path, the path for to find f1, f2, f3 up till fk, like the optimal path. So let's say in this path I choose 5. Now the next job is to find the optimal split for the number 20 into so in the first case it was 2 here. So now the next job is to find the optimal path for number 20 such that it can be splitted into just one positive integer, because since the total you have to find out two numbers, one you have already taken, so one is this one itself, right? So since this is 20 which is not equals to 1, means that we have to take 20 itself, no other option. So this is one of the split, but is it optimal? So here the difference between mean and max is 15, but we could have done better, right? So let's say in the another path we taken 10 as a first place, right? 10, because 10 is also one of the divisors of 100. So let's say I took 10 here. Now the next job would be to find total 100 divided by 10. Split 10 into one positive integer, so there is just one option, 10 itself. See, this is the most optimal because the difference here, the mean and max is 0, which is the minimum possible, right? So this is how we do it. We kind of try a brute force approach. We keep on choosing divisors from the divisors array and we try to find out the most optimal path. So keep 5 here, then 20 here, just check if this is optimal. If it is not optimal, remove it, keep on inserting some other number and all. So I would highly recommend to solve a backtracking problem, then it would be easy for you to understand, right? So yeah, this is the explanation part. Now let's see how we can write code for it. This is the code of second problem. So we are given n and k, right? So I used 3 variables, one to store all the divisors. This is my answer, and this is my, like, the optimal path. So now here what I have done, I have found all the divisors of the given integer n. So this is how we do it. We keep on iterating from 1 till I into I less than n, I plus plus, and we just check if the current I is the divisor. If that is divisor, so this is one of the divisors. So see, for any number n, if I is one of its divisor, n divided by I is the second divisor. So I inserted n divided by I as well. So this will calculate all the divisors. Now I have sorted because they could be in a random order, right? So I sorted it. So it would be, so it will look like this way: 1, 2, 4, 5, 10, 20, all in a sorted form. So for the divisor 100, it will look like this. So now what I'm doing here, I'm doing a backtracking for the given integer n, and at the end return your answer. So let's see what this backtracking does. It first check if my current path had size equals to k. So this is my current path, right? So k means that like we have so we have considered k number of splits for the given integer n. If it is k, just check if, so see, if you split it into k positive integers, your total multiply should be equals to n, right? In other terms, if you keep on dividing all the numbers from the path, your ultimately it should result down to 1, right? So if you divide by 100 divided by 5, 20 divided by 20, it is 1, so it should result to 1. So if it is not equals to 1, means this is not the valid path. Now if it is 1, means that we have found a valid path. So just check if it is optimal. So just check if my current path, like the difference between maximum and minimum is lesser than the stored answer. If that is true, just update your answer and return from here, right? So this is how we found the optimal path. Now if it is not, like if the size is not equals to k, means that you need to split again into some positive integers. So what I'm doing, I'm going through all positive like all the divisors in the given divisors array. I'm just checking if my current n is divisible by x. If that is true, and like either my path is empty or this number should be greater than my current like the maximum number in the path, because I want to find a path such that each number are in increasing order, right? Because see, this is a backtracking, right? So we need to find a concrete way to distinguish between two different duplicacy. So to avoid the duplicacy, I'm kind of having a way to such that all the numbers in the path should be in increasing order. It could be in decreasing order as well. It's completely up to you how you try to implement it. It's just to avoid the duplicacy and some randomness. So I just check if my current path is empty and this current number is greater than the maximum in the path. If that is true, just like insert this into the path, do a backtracking again, and then pop it back. So like so if you have solved any backtracking problem before, you would have like encountered this before as well. So what we do, we insert it, do a backtrack, and then pop it, right? And ultimately it will take care of finding the most optimal path. So yeah, this is the code of second problem. Now let's see the third problem. In the third problem, you are given an integer array nums, and your task is to find two distinct indices I, j such that the product of these two numbers is maximized. And the condition is your nums of I and nums of j must not share any common set bits. And we have to return the maximum possible product of first pair. If no pair exists, return 0, right? So this is I would say a DP plus bit masking problem. Bit masking because we have to play with this binary representation of nums of I and nums of j. I mean the numbers present in the given array nums, and the DP because we have to find out the most optimal pair, right? So yeah, let's see how we can approach this problem using DP plus bit masking. As mentioned, we will solve this problem using DP plus bit masking. DP plus bit masking. So let's see how we can approach this. So we will create a DP array, 1D DP array, where DP of I will tell you the maximum possible number in the given original nums array, configuring all if states by changing any of its set bit to 0. What it means, let's say I configure I the set bit of any number I is 1 1 0 1 1 0 0 0 1, right? So DP of I will be the maximum of configuring all states by changing any of its set bits to 0. DP of, so instead of I will write in the binary representation, it could be either 1 1 0 1 1 0 0 0. Let's say I change the set bit to 0, it will configure this. Other possibilities could be, let's say I change this set bit to 0, it will be 0 1 0 0 1 1 0 0 0 1, right? Let's say in the third state, maybe I change this 1 to 0, so it will be DP of 1 1 0 1 0 0 0 0, right? And so on, right? So this DP of I will tell you the maximum possible number in the original array, configuring all its sets by changing any of its set bit to 0. So this is the first calculation, right? We will find out the maximum. Let's see how we can build your answer, because you have to find out the product of two numbers such that they do not share any of its common set bit, right? they must not share any common set bit. That is why I did this part, to store the maximum value such that one of the set bits is unset from 1 to 0. Now once you do that, your job is pretty easy. Now what we will do, we will iterate through all the numbers in the given number. Let's say this is my num in the given nums array, right? What we will do, we will first check if my dp of let's say this is my nums. So let's say the binary representation of this current number is let's say 10110, right? What we will do, we will try to find the jar of it. So it would be 01001, right? Now what I will do, I will try to check if the dp of this 01001 exists or not. If it is not, if it doesn't exist, it means that this is not possible, because see, you can form a pair of this number, this 101102, any of the number which does not share a common set bit, right? So it means that this and this must always be 0. This is my second place, 0 0, this is the third place. It could be either 0 or it could be either 1, but these three numbers must always be 0, because in the problem it says that we cannot configure two indexes that share a common set bit. So these set bits will definitely be 0 in the second number which is present in the given array, right? So if you see here, this should be 0, right? So what I did here, I took a jar of it. So in the jar, these numbers will always be 0, right? And for these numbers, your dp will take care of it, because we know that for dp, we know that here it could be either 1 or it could be 0, and dp of I exactly what gives me, it gives me all the the maximum possible number in the original array, considering all of the states by changing 1 to 0, and that's what exactly I want. For 1 I wanted the maximum answer from 01001, 01000, or 0010001, or 00000, right? And all these four states would be stored here in the dp array. So and that's exactly what I wanted here. If this is not equals to 1, it means that your answer exists. If it is equals to -1, means that there is no possibilities of number in the original array. So just return or continue here. But if it is not equals to 1, means that the number is present there, right? So in that situation, your answer will be maximum of answer comma your current number num into this dp of this jar of it, right? Exact jar of it. So for 10110, the jar is 01001, right? So yeah, in other terms, if you want to make it generalized, it will be the all I will tell you what is this all, jar num. So all means all the set bits are set. So to find out the exact jar of this number, what you do, you take jar with the original 111, all the bits set. So if you the jar of 11 is 0, and the jar with for 0 it will be 1, right? So yeah, this is the code of, this is a pretty easy DP plus bit masking problem. I've seen pretty hard problems as well, but this is a very minimal one, right? So let's see how we can write code for it. So yeah, this is the code of third problem. So as mentioned, so this is my nums array. I first found the maximum number present in the given array nums, and this is my power. This power will tell you the maximum power of 2 for the given number max. So I found the max number. Then I calculated the max power. Now here is my dp array. So as mentioned, dp of I equals to maximum possible numbers in the nums array considering all states by changing any of its set bit to 0, right? So yeah, and now originally for dp of nums it would be nums itself, right? Now once you updated for the dp of I itself, dp of I will be I initially. Now what I'm doing here, I'm changing all the states, as explained here, your dp of I is the maximum of among all these possibilities, all these states. That's exactly what I have done. I'm going through all the powers and one left shift power. I'm just checking if the current set bit is 1, if the current bit is set, dp of I equal to max of dp of I comma i's or one left shift j. So what I'm doing here, I'm just changing it 1 to 0, and I'm trying to updating my current dp of I. Right, so dp of I is updated here. So once this updation part is done, as explained here, once you updated the dp value, like build the dp value, now what I'm doing here, I'm going through all the numbers in the given nums array. I'm just checking if taking exact jar of it is -1 or not. If it's -1 means like the number is not does not exist in the original array, right? If it is not equals to -1 means then the dp value is found, like the other pair is possible. So just update your answer. Your answer is equal to max of nums comma dp of all jar nums. So all means this, all the set bits are 1, right? So yeah, this is the code of third problem. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching. Have a nice day.